The metaverse, a novel digital realm, requires robust infrastructure to facilitate immersive experiences. Artificial intelligence, augmented reality, virtual reality, and cloud computing are essential components of this infrastructure. Asset digital twins, virtual replicas of real-world objects, are crucial components of the metaverse, enabling users to engage with digital content in a highly immersive and interactive manner. However, developing asset digital twin infrastructure poses technical and creative challenges, including data storage, retrieval, and streaming bandwidth. To address these challenges, a modular framework is proposed, offering flexibility for independent customization of individual system components. This framework is validated through the English PEG solitaire game as a use case, where a solution tree is generated using the breadth-first search algorithm. The results demonstrate a data-driven 3D animation system utilizing motion primitives, which is adaptable and modular, making it applicable to asset digital twins across diverse business contexts. The presented methodologies and infrastructure lay the groundwork for pilot applications in education, health, or Industry 4.0 material development, and can be tailored to various use cases. The significance of 3D character animation, often referred to as avatars, in implementing the metaverse is emphasized. Traditionally, this is achieved through costly motion capture technologies. The proposed framework offers a more affordable alternative, enabling the creation of realistic avatar systems. By integrating various technologies, this system enables the creation of virtual replicas of physical assets, facilitating immersive experiences in the metaverse. The metaverse demands the creation of aesthetically pleasing 3D models and animations that accurately capture real-world objects and environments, necessitating interdisciplinary approaches. By combining expertise from various fields, organizations can overcome challenges in metaverse development. The metaverse offers novel opportunities for collaboration, automation, and remote operation, enabling remote monitoring, control, and manipulation of robotic systems. It allows for the simulation of complex scenarios, accelerating the design and optimization of robotic algorithms and behaviors. This can enhance human-machine interfaces and automation, shaping the future of robotics. The research integrates gamified virtualization into the world of robotics, focusing on dynamic 3D animation for immersive experiences such as board games. Key contributions include the presentation of an underlying inspiration for customizing and adopting digital twins in various industrial business domains, the introduction of a novel asset digital twin framework, and the creation of a new baseline approach for pilot projects with software materials for Industry 4.0 use cases. The study adapts the solution tree calculated by the breadth-first search algorithm to extract motion features and validates the proposed framework through a case study of a board game. Metaverse opportunities have been applied to various industries, including smart manufacturing, education, healthcare, and intelligent driving, leveraging digital twins for predictive maintenance, performance optimization, and decision support. Digital twins, which replicate physical objects, processes, or systems, have been extensively utilized in these industries. A specialized type, asset digital twins, focus on replicating individual assets within a larger system and have been applied in manufacturing, transportation, education, and healthcare. Research has explored the use of digital twins in Industry 4.0 scenarios, connected vehicles and pedestrians, and robotics, yielding significant benefits. The Unity engine has been employed to provide multi-platform and cross-platform tools and realistic virtual environments for implementing domain-specific simulations and animations. This has been demonstrated in robotic domain simulations, logistic scenarios, and sign language reproduction systems. 3D character animation development has been utilized to simulate real-world scenarios effectively, with generative models proposed for character animation and virtual patient avatars for care and nursing training tasks. The breadth-first search algorithm has been applied to various applications, including mining top high-average utility items and finding a path for the labyrinth game. This study aims to establish a practical framework for creating asset digital twins that integrate an intelligence component with a computational layer and animation. To achieve this, a board game use case has been designed, utilizing readily available tools and lower-cost techniques. In the context of Industry 4.0, The digital twin framework plays a vital role in creating diverse educational materials and bridging the physical and virtual worlds. A digital twin is a comprehensive representation of industrial processes, encompassing manufacturing, smart automation, and predictive analytics. This study introduces a novel asset digital twin framework for animating avatars based on specific scenarios. The proposed framework consists of 4 primary digital twin types: component twins, asset digital twins, or product digital twins, system twins, and process digital twins. An asset digital twin comprises multiple components, enabling the analysis of integration and interaction of each part, and identifying potential improvement cases and system performance. Motion primitives are fundamental building blocks for automating motions in motion planning and control algorithms. These primitives possess 4 key features: composition, reusability, parameterization, and simplicity. They correspond to basic movements, comprising a set of discrete pre-computed motions that an actor performs to accomplish a specific task or sequence of actions. Atomic actions, essential units of motion or activity within a video sequence, are frequently applied in computer vision and video processing for activity recognition, motion tracking, or action detection. Motion primitives serve as foundational components of 3D animation and simulation, streamlining the animation process, improving productivity, and offering flexibility for creative experimentation and refinement. The proposed asset digital twin framework architecture consists of 3 primary components: a smart computing part, a digital 3D animation part, and a data transmission file between these modules. The user interface features a text box for selecting a score and an animated video as output. The digital replica of the animator and simulation objects are represented within the Unity engine. The virtual environment comprises a motion primitive database, a C coding layer to control animation, and the generated animation. This novel framework enables the creation of diverse educational materials, connecting the physical world to the virtual environment, and facilitating the analysis of complex assets and system performance. This case study delves into the development of an asset digital twin with avatar capabilities, leveraging a cost-effective 3D animation technique. The primary goal is to establish a versatile framework that enables the utilization of virtual representations of assets across different industries. The proposed systems architecture integrates the intelligent logic in the Evaluation Application Programming Interface (API), with its digital version by 3D character animation. This process allows for the creation of user choices through a graphical user interface (GUI), ensuring that the 3D animation is automatically performed in the digital version after selection. A graphical representation of interconnection in the asset digital twin system between the phases of 3D character animation development is presented. The discrete animation system functions as follows. Evaluation API for logic is implemented, integration to the digital line is ensured, and the digital component interacts with users, i.e., a specific scenario is executed as 3D animation. The task at hand focuses on establishing an asset digital twin infrastructure integrated with 3D animation capabilities to enhance various use cases, particularly in robotics and industrial automation, and also including board games. The primary objective is to establish a versatile framework that enables the utilization of virtual representations of assets with components ranging from digital data creation to 3D characters and environmental elements. The task encompasses several key components, including data generation for the game search tree, a user interface for choosing a specific game score, a .csv file for the integration, and 3D animation creation for the stated scenario, namely the board game asset of PEG Solitaire. Additionally, it ensures development to facilitate the creation of asset digital twins with seamless integration into product pipelines. In this work, iterative prototyping, testing, and validation of the asset digital twin infrastructure are conducted to evaluate its scalability, performance, and compatibility with specific use cases such as board games. PEG Solitaire is a classic single-player board game enjoyed by players of all ages that requires strategic thinking and puzzle-solving skills. The objective is to remove pegs from the game board by jumping them over adjacent pegs until only one peg remains. The breadth-first search, BFS or level-order traversal, algorithm is used to traverse tree data structures in which all nodes at the same depth are explored before traversing to the next depth level. Generally, a queue is used to hold and track the kept tree nodes within one connected component. The traversal order of the BFS is illustrated in Fig. 4. This algorithm has many potential use cases for solving various problems in real-life scenarios, such as game search trees for chess, pathfinding with virtual maps, GPS navigation, and more. The authors of the research paper discuss the diverse applications of breadth-first search, BFS, algorithms, including their use in robotic systems, network security, and social networking. Figure 4 illustrates the tree structure and node order in the queue for the BFS algorithm, demonstrating its ability to guarantee finding a solution node or path if it exists, as well as its ability to find the shortest path. The BFS algorithm has several advantages, such as low storage requirements, linearity, and ease of programming. However, it also has significant memory requirements, making it unsuitable for large-scale problems. The time complexity of the BFS algorithm is expressed as O, V plus E, where V represents the number of vertices and E represents the number of edges in the graph. To optimize the BFS algorithm, the authors suggest using queues instead of recursion, performing parallel calculations, and prioritizing nodes. They note that the best optimization technique depends on the problem statement and data type. The authors then present a customized BFS algorithm, described in Algorithm 1, which is applied to calculate the game solution tree based on the rules. The customized BFS algorithm includes two main functions, a main process and a function called once per node. The main process generates the solution tree in a database via BFS, while the function called once per node generates children nodes for each node as a queue structure in the tree in the database. The authors provide pseudocode for the customized BFS algorithm, which includes functions such as insert record_db, read record_db, generate children, and move up, move down, move right, and move left. These functions are used to generate and save the solution tree to the database via the customized BFS algorithm. The development of 3D character animation with customizable 3D avatars in the Unity ecosystem is explored. Unity, a cross-platform graphic environment, is utilized for creating 3D and 2D animations and simulations due to its versatility and flexibility. Key Unity concepts, such as the Animation API and Editor, are highlighted for their advantages in facilitating avatar development. Rigging, a crucial step in avatar creation, involves the construction of a skeleton and constraints. This process is achieved through the C Animation API, enabling precise control over avatar movements. Inverse kinematics, IK, and motion interpolation are also employed to ensure realistic and smooth animations. IK resolves the complex problem of calculating joint movements, while motion interpolation facilitates seamless transitions between animations. Avatar construction in the Unity editor involves combining a character model, skeleton, and bone mapping. Animation trees are used to integrate animations, with parameters such as speed, throw, and dance controlling the animation flow. State transitions between different statuses are critical, with conditions for transitioning between idle, run forward, mining loop, and dance states clearly defined. These transitions are detailed in a table, illustrating the specific requirements for each state change. Figure 8 presents sample sequential frames of video clips, showcasing motion primitives of 3D characters in various states, including idle, run forward, mining loop, and dance pack animations. These predefined actions are used to generate logical animations via the proposed solution. The pseudocode in Algorithm 2 outlines the procedures for evaluating trajectories and driving 3D characters. The main process, animation main process, reads a CSV file, parses each line, and chooses or destroys predefined egos based on game scores and move indices. The function process frame character movement, called once per frame, calculates the character's direction and movement based on target indices and move indices. The experimental results are divided into three subsections: data generation, integration file, and avatar simulation. The data generation process employs the breadth-first search, BFS, algorithm to generate a game search tree for PEG solitaire. The algorithm utilizes a queue and database to calculate and store the solution space for the problem. A Java procedure calculates the moves in the game solution tree, and the game tree is saved in the database. To accelerate the search algorithm, an elimination strategy is developed, enabling the calculation of final scores within a reasonable time. This procedure generates 8,585,713 nodes and 37,397 solutions, which are stored in the database. The development of a game search tree for a PEG solitaire game utilizing the breadth-first search (BFS) algorithm is presented. The solution tree is constructed by calculating scores from 1 to 26 and transferring these game moves to a .csv file, which contains indexes of pegs to be jumped, moved, and removed in order, ensuring avatar position control. Java and Microsoft Access DB were employed for programming stages. Sample results of data patterns from the DB are showcased, illustrating the game search tree according to tree-level order and queue structure. Solution tree nodes with calculations and iterations are also provided. A queue structure is utilized to store nodes in each level of the solution tree, commencing with the initial state or root node at level 1. Child nodes are calculated based on game rules and added to the queue at level 2, repeating this process for each level. The node structure consists of a level for movement number, a number for queue sequence, data for representing peg numbers on the board, and parent_level and parent_number for linking the node and the parent of the node in the tree hierarchy. The BFS algorithm is applied to create the solution tree, starting from the root and applying the rules to generate child nodes. Each iteration adds one more level to the tree, making the number of iterations equal to the height of the tree. The integration file, as shown in Table 6, includes the final digital pieces of information and is used to drive the motion. It includes sample movement attributes in a .csv file, which includes game_id, game_score, and move_index attributes. The file is used to drive the motion and is generated based on the game scenario. The avatar simulation is a crucial step in generating asset digital twins in the virtual world for the metaverse. The researchers implemented a prototype for a 3D character animation system compatible with multiple platforms, including PC and Android mobile applications. Unity was selected as the virtual simulation environment for avatar animation and interaction due to its superiority in comprehensive animation and simulation development ecologies. The modeling process and workflow of the program involve the user entering the desired score on the GUI screen, selecting movement attributes from a file to prepare the animation scenario, and changing the animator status from idle to run forward. In the animation pipeline, a scenario-based approach is employed, where the avatar's movement is decomposed into stages realized by motion primitives and the coding layer. This decomposition enables the concatenation of predefined motion clips based on the scenario, as illustrated in Figure 11. When the animator reaches the desired peg, a collision occurs, and the hand picks up the peg, initiating a new movement cycle. The animator's status changes from run forward to mining loop, and then to idle, as the peg is placed in its new position. This cycle continues until the end of the game, at which point the score is calculated, and the game ends with the animator dancing. The proposed asset digital twin pipeline is validated through extensive experiments, as shown in Figure 12, which demonstrates the generation of smooth animation based on a predefined scenario using motion primitives with a cyclic pattern. To evaluate the animation performance, comprehensive experiments were conducted to gain insight into the proposed framework. The performance evaluation of the game involves measurements and performance calculations for a recording from gameplay, with emphasis on 60 FPS count, CPU usage, the rendering process, and memory. A case study was conducted on a board game with 32 pegs that appear in order, with data recording taking place on a personal computer using the Unity profiler. The results show that board games are more stable compared to other games where characters are animated according to their motion sequences. Performance analysis of the game under investigation reveals a stable and efficient rendering process. CPU usage and memory consumption during gameplay are assessed, with profiler graphs in Figure 13 demonstrating stable CPU usage with rare spikes, maintaining a consistent frame rate of 60 FPS. A detailed breakdown of frame data in Table 5 shows excellent results for set pass calls, draw calls, and batches, contributing to the game's overall performance. Memory usage is also evaluated, with a total allocated memory of 0.90 GB and total used memory of 242.4 MB, as summarized in Table 7. These findings provide valuable insights into the game's performance and efficiency, highlighting its stability and low memory consumption. The rendering process demonstrates a high degree of stability, with the frame rate consistently maintained at 60 FPS, indicating efficient resource allocation and utilization. This paper introduces a data-driven avatar-based 3D animation system in Unity, tailored for a specific use case. It showcases the potential of asset digital twins by integrating programming logic and avatars in the context of a board game, Peg Solitaire. The framework comprises an algorithm, a digital world via Unity, and data transmission via a file between the intelligence logic and the digital spaces. A sample use case was established to validate the architecture of the framework, and the asset digital twin system was further validated in a board game application. The Java and DB platforms constitute the driving animator to animate the scenario, while the 3D character option of Unity is used to produce the animation environment for the board game. Data transmission between different platforms is provided by a file structure with attributes matching movements. The presented asset digital twin framework is expected to serve as a powerful architecture for future research on digital twin technology. This could enhance software tools and applications in manufacturing, safety, education, health, and mobility. The page discusses various applications and technologies related to digital twins, Metaverse, and their integration with robotics, artificial intelligence, and machine learning. It includes detailed explanations of how these technologies can be used to enhance simulation, prediction, and decision-making in complex systems. The integration of digital twins with AI and ML enables real-time data analysis and feedback, improving system performance and efficiency. The Metaverse is also explored as a platform for immersive and interactive simulations, further enhancing the potential of digital twins in fields such as manufacturing, healthcare, and urban planning. Senem Tanberk, a renowned expert in computer engineering, has over 15 years of experience in the telecommunications, finance, and banking sectors. Her areas of expertise include telco pricing and billing, revenue and financial reports, DWH support, software design and development, and advanced place SQL optimization. She is also a telco Oracle Place SQL trainer and currently works as a research and innovation manager in a private company in Istanbul. Her research interests are deep learning, data science, robotic programming, 3D character animation, and simulation programming.